Hello and welcome to this session where we focus on our applications for CO2. We will today present 3 different systems. We will start with the normal booster system, then we move over to the transcritical system with IT compressors, and finally we will focus on our CALM system, CO2 Adaptive Liquid Management, where liquid is possible within the system. First, we will move over to the mobile training unit where we again have sent Brian and Shemek. So we start with the most simple one. Are you ready, Brian?
Yes, exactly, Anja. It's good to be back again today, and I will talk about the simple booster system. This was the first transcritical CO2 application that was scaled and commercialized. And this is the one that was the most commonly used for many years, and even today this is probably still the most commonly used, since it's the simple one. It's the one with the lowest first cost. So if we look at the application drawing here on the poster next to me, then we have the refrigeration system here going this way around. And if we start on this side, then we have the medium temperature compressors here with the suction line from the MT and LT cabinets. The MT compressor does the work and lifts the gas to a level which is up above 100 bar, maybe up to 120 bar, which means that we can, with a good temperature and pressure control in the gas cooler, we can control the refrigerant at the optimal point and achieve the highest efficiency of the CO2 refrigeration system. We are using the fans, controlling the fans to control the temperature, as we are using the high pressure valve to control the pressure of the gas cooler. And here on this drawing we see the CCMT Lite, which is a new valve that has also been introduced yesterday. We have in various places, we also have the DBCT shut-off valve, and depending on the design of the pack, you can locate it in different positions so that it is possible to isolate the individual components and do easy service and maintenance on the system. The high pressure valve throttles the gas down to the pressure level that you want in for the receiver. And in the receiver, the refrigerant is separated, so the liquid will drop to the bottom, and if there is any gas, depending on the quality of the refrigerant, this will stay in the top of the receiver, obviously, and here, unless we do something to control this gas actively, then the pressure will build up and eventually the receiver will burst. And this is where the gas bypass valve comes into the picture, also here illustrated with the CCMT Lite valve, which is throttling the gas from the receiver pressure, typically around the 35-40 bars, down to the evaporating pressure of the MT compressors or the MT evaporators. The liquid in the receiver is led to the MT cabinets, where we have the Danfoss case controller with the AKV valve on the MT side, and we have liquid coming down to the LT cabinets, where we will also have the Danfoss case controller and the AKV valve. And that closes the loop with the MT gas coming back to the MT compressor and the LT gas coming to the LT compressors. And the LT compressor lifts the gas to the evaporating pressure of the MT compressors, and in this way we talk about a booster pack, and hence the name, a simple booster system. So that is where this comes from. The whole system is managed with the Danfoss pack controller, typically for smaller packs. It could be the 572 that is used as a controller, combined with the CCMT Lite valve and the Danfoss case controller. So this is the whole system. One of the challenges with CO2 systems, and this is where we see the technology has evolved over time, is that this system is most efficiently in colder climates when you have a high quality of the refrigerant, meaning that you produce little gas that has to be led back to the MT compressors. And this is where the next technologies come into place, like the parallel compressors and also the Danfoss multi-ejectors. But that will be the topic of the next introductions that we do here during the day. So back to you for now, Anja.
Thank you, Brian. That's exactly right. So over to you, Szymek. Can you tell us more about a transcritical system?
Hello, everyone. Today I have a pleasure to present to you transcritical CO2 system with IT compressors enhanced by the Danfoss multi-ejector solution, which is a bundle of the CTM multi-ejector and the AKPC 782 pack controller. And we should not forget about the overall package, which also contains the case controllers and the system manager. That is one of the newest developments coming from Danfoss, taking the refrigeration systems to the next level. When it comes to the multi-ejector, we are having one big aluminum block, the CTM6, and there are 3 different code numbers containing from 4 up to 6 individual ejectors. What is very important is that the individual block is able to cover the applications from 35 up to 140 kilowatts. And in case you need to increase the capacity, you can simply connect up to 4 blocks in parallel, and thanks to that, you can serve the bigger systems as well. Let's have a closer look on the poster. The CTM multi-ejector, it is located here, and it is between the gas cooler and the receiver. One of the things which you can immediately notice is there is no high pressure valve. The multi-ejector takes over its functionality and it gives much more. At the ambient temperature of 35 degrees of centigrade, it is able to move approximately 50% of the CO2 leaving the empty cases and bring it to the multi-ejector, mix it with a gas coming from the gas cooler, and then send it to the receiver. This pre-compressed gas is then taken by the IT compressors, which operates more efficiently because there is a higher pressure on the suction side of those compressors. The IT compressors, they are moving approximately 70% of the total mass flow of the refrigerant circulating in the system, and thanks to that, they are improving the overall system performance. With the Danfoss multi-ejector solution, we can proudly say that the CO2 equator has been eliminated completely, and you can use those systems in any store globally. Thank you, and back to studio.
Now I have introduced our normal booster system and a transcritical system. We have taken the best of both worlds and just added liquid in a system, and there we have the calm solution. So it's not so completely different. Or what do you say, Brian? Take it away.
Thank you very much, Anja. It's not that completely different, but it's a new flavor of the multi-ejector solution from Danfoss, and we call this the CO2 Adaptive Liquid Management Solution. And this is introducing another ejector type and also a new component in the system. And I'm standing here next to the pack in the mobile training unit, and if we look at the bottom, then we have the ejector here, the multi-ejector, and this is a combi block, so we have 1 or 2 individual ejectors that is moving liquid, and we have 3 or 4, depending on the size of the block, ejectors moving gas. So this is the combi block here. It could also be a liquid-only ejector where we would then have typically only 1 or 2 cartridges. The other component in the CO2 Adaptive Liquid Management Solution is the suction accumulator, which is there to prevent liquid that comes from the evaporator from reaching the compressor. So that's part of the safety of this system. But let's have a little bit look first at the efficiency and also the first cost aspects of this, because we are introducing new components, and this means that the first cost of the installation goes up, but with the calm system there is a very low payback time on this additional investment. And basically the reason why we can deliver a good return on investment with the calm solution is that the liquid that we have in the system is very, very limited. We are not running the system flooded as we know it from traditionally ammonia system in the industrial refrigeration side. or also from other systems that are used in commercial refrigeration. So we really have a system that delivers very, very little refrigerant. And this means that the suction accumulator, where we have the droplets coming out, the refrigerant coming back from the evaporator, can be dimensioned very small, and that means that this cost driver has a limited impact on the whole installation. Also, the extra efficiency of the system means that you have less need for compressor capacity, and that means that you can have smaller and you can have fewer compressors. So there's also a first cost gain on that side, helping to have a low return on investment. And finally, you can argue that since the whole system has less refrigerant, we have a smaller accumulator, then also the traditional receiver in the system can possibly be dimensioned smaller. So this is the first cost aspect, you can say. Then on the efficiency side, we have updated the already market-leading dry expansion algorithm, superheat algorithm in the Danfoss pack controller. And this means that we are now, where we typically in the past, or with traditional dry expansion process, can go down to maybe 3 Kelvin of superheat, then we can get very close to 0 Kelvin of superheat. And that means that we are utilizing the coil of the evaporator fully. So the most loaded cabinet or the most loaded room, we will utilize the coil fully, and that means that we can change the suction temperature, the suction pressure of the compressors. And we know traditionally that for every degree Kelvin we can change the suction temperature, we also save 2 to 3% of energy on the whole refrigeration system. So that's really a big benefit to go for. So that is the efficiency. The reason why we only have very little refrigerant coming back to the system is that we are running close to this 0 Kelvin, and this means that there's only droplets coming out of the evaporator. And if you have from the most loaded evaporator, and if you have a system with 10 or more evaporator, then you will typically have a quality of the refrigerant at the accumulator of maybe 3% liquid. And this very little amount of liquid combined with the efficiency of the ejector means that we are able to remove all the liquid from the accumulator, and that you don't have to dimension the site with a parallel pump or similar to move liquid. There might be some cases where you need to leave the calm mode to prevent that an error in the system starts to build up refrigerant in the accumulator, and therefore risking to damage the compressors. So we have some safety precautions in the system. And if we move to the poster on the wall here, then we have a diagram that we have seen before. And here we have the combi ejector, or we have the liquid ejector. And you can see the components where we have made changes. We have changed the case controller, where we have the ALK algorithm, extended the dry expansion algorithm. We have the pack controller that is safeguarding the system, and we have the system manager that has also been updated to assist with the coordination between these components. The safety of the system is protected in the way that we can change the mode from the adaptive liquid control, where we have liquid droplets coming out, to a fully dry expansion where we have 3 Kelvin or more superheat, and in that way preventing more liquid to come to the suction accumulator. This mode is changed by the pack controller, so we have a liquid switch on the accumulator, or the pack controller is detecting that now the liquid ejector is coming out of the operational envelope, and then as a precaution it tells the system manager, now we need to get the case controller, the evaporator controller, out of the adaptive liquid control mode with the droplets and go back to the dry expansion. So this is the way that we have optimized the full system, and also guaranteeing the safeguard of the system and protection of the compressors. So that's all about the CALM system. So back to you in the studio, Anja.
So that was the 3 applications we would like to demonstrate for you guys today. I hope you liked it. If you are keen to know more about CO2, I can recommend you to stay tuned and watch our hands-on session focusing on CO2 products. Now, the product managers and I will go into the chat room. I encourage all of you to come and join us, and let's have a dialogue. Thank you.